Yes. Okay then. Yeah, just nice. Okay, shall we start? Okay, today we are going to have Mr. Paul Velangani's Viva boss examination for IIC doctorals research. I am Achimani Chardi, one of the assistant professor for IIC University of Technology Cambodia, and I have my colleague here, Mr. Desmond, just completed his PhD. So he's Dr. Desmond now. So from now on, you'll be given around 30 minutes to present your first part. After that, you can take 5 minutes for your short break. Thereafter, you can continue for another half an hour to complete your entire research on your based on your thesis. Okay. So, Mr. Paul Velangani, you will be given time from now on. The time is now 6:34. You can start right now.
Okay, very good evening to doctors, and my name is Paul, and the topic that I'm going to present today is using Kaizen method to eliminate negative photoresist non-coating detection issue in manufacturing industry. This is a topic that I worked on, and it reached the fruition stage. So now I'm going to present it as my thesis topic. So before I go further, let me give you a self-introduction of myself. My name is Paul, and I have a Master of Science in Management from University of Utara Malaysia, and I have a Bachelor of Science in Electronic Electrical Engineering from Robert Gordon University. Okay. Right? So next, I'll go through some of the concepts that I'll be using in my thesis presentation today. So before I go further, let me start with the introduction to Kaizen. So what is Kaizen actually? Kaizen is a Japanese word for improvement, and when it's used in the business sense and applied to the workplace, Kaizen refers to activities that continuously improve all functions and involve all employees from the CEO to the assembly line workers. So Kaizen is for everyone, from top to the bottom line workers. It also applies to processes such as purchasing and logistics that cross organizational boundaries into the supply chain. It has been applied in healthcare, physiotherapy, life coaching, government, banking, and other industries. By improving standardized activities and processes, Kaizen aims to eliminate waste. Kaizen was first implemented in several Japanese businesses after the Second World War, and it is influenced in part by American business and quality management teachers who visited the country. It has since spread throughout the world and is now being implemented in environments outside of business and productivity. So what it says here is that the Kaizen activity actually started after the World War, when many of the management teachers from all over the world, and also especially from America, visited Japan for their development. So Kaizen was first conceptualized at that point of time, and from there to now, Kaizen has been implemented all over the world, and it has been considered as one of the main source for any improvement activities. So Kaizen basically means change for kai and zen for good. So it is a compound word involving two concepts, kai change and zen for the better. The term Kaizen itself comes from the word Gemba, Kaizen meaning continuous improvement. Continuous improvement is one of the core strategies for excellence in production and is considered vital in today's competitive environment. It calls for endless effort for improvement involving everyone in the organization. Ime is one of the person who have worked extensively on Kaizen, and he has defined Kaizen as an ongoing improvement involving everyone, including both managers and workers. The Kaizen philosophy assumes that our way of life, be it our working life or social life, deserves to be constantly improved. So next, on this slide, I will talk about the background of Kaizen. Right? So as I mentioned earlier, the challenge of rebuilding Japanese business from scratch after World War II, the oil crisis in 1970s, and the resultant economic challenges that ensued in the 80s and 90s. For example, increases in the cost of raw materials and labor, increased international competition, changing consumer values and shorter product lifestyles collectively provided the impetus for the rise of process-oriented management and manufacturing strategy of Kaizen. Various tools were introduced to Japan in the 1950s and 60s by American experts such as W.E. Deming and J.M. Duran, who are pioneers in this field. So they actually introduced the quality control, but this was subsequently developed in a very Japanese way, so that Kaizen is now an umbrella term encompassing many management practices such as total quality control, circles, productivity improvement, zero defects, just in time, and so on. So what was started by W.E. Deming and J.M. Duran actually evolved to the environment of Japan, and it became a Japanese thing.
Is that possible to produce zero defect?
Zero defect are not impossible to achieve, but there's a lot of efforts that goes to it, and it really depends on the type of manufacturing that we are looking at.
Okay, go on.
So having talked about Kaizen, next I move to another context that we will be using vastly in our presentation today, photoresist. So what is photoresist? Photoresist is a material that is photographically exposed and processed and used to resist a sandblast stream and thereby transfer a pattern to the object being sandblasted. So globally, there are two types of photoresist. One is a positive and the other one is a negative. Positive resist is exposed with UV light, and the exposure to the UV light changes the chemical structure of the resist so that it becomes more soluble in the developer. The exposed resist is then washed away by the developer solution, leaving windows of the bare underlying material. Negative resist behave in just the opposite manner. The negative resist remains on the surface whenever it is exposed, and the developer solution removes only the exposed portion. So example of this is our old negative that we use for camera. Okay. So what is the application of photoresist? This technology is widely used in worldwide, especially in Asia, for the following application: fabrication of printed circuit board or PCB boards. This can be done by applying photoresist, exposing to the image, and then etching using iron chloride, cupric chloride, or an alkaline ammonia etching solution to remove the copper clad substrate. Next is also used extensively in sand carving. Sandblasting of materials is done after a photolithographically printed pattern has been applied as a mask. Microelectronics. This application applied to silicon wafers, silicon integrated circuit, is the most developed of the technologies and the most specialized in the field. So under microelectronics, we have many companies such as Infineon, Siltera, that uses this technology to develop their wafers. And out of these four, by far, microelectronics is the most complicated one, and it takes a lot of effort to develop the pattern on a wafer. So finally, patterning and etching of substrates. This includes specialty photonics materials, MEMS, glass printed circuit boards, and other micro patterning tasks. photoresist tends not to be etched by solution with a pH greater than 3. So the company, this study is done in a company, and this company in particular uses the fourth application, which is the patterning and etching of substrates. Next, I move to company X. So the name of the company is not revealed here as it's confidential information. Right? So some basic introduction of company X. Negative photoresist is widely used in many companies. For this study, the improvement done in a company will be studied in a Kaizen context. That is the main idea of my research work. Right? So some background on company X. Company X is actually located in the northern side of Malaysia, and the company uses negative photoresist technology widely to coat its product for the patterning and etching of substrates.
What about your company? Do you people involved in any kind of this kind of system in your company?
Okay, actually company X is the company that I'm working with now, but it's not easy to get approval from MNC.
Disclose their information.
Yes. So company X, I'm actually working in company X. So this thesis will be on the research work that I've done for this company.
It's purely industrial.
Yes, purely industrial. So next, negative photoresist. Okay, in this company, the name of the machine is also named as negative photoresist, or its acronym NPR. So the picture that shows the machine, right, is contained with curtain, right, and it has its own exhaust, right. So NPR is an equipment used in company X as an application to separate each cell and prevent short circuit forming between cells. This film is rolled onto the surface of the panels, arriving in the applying unit after sensed by a sensor which invokes the linear path control to start lowering the upper applying unit. Rotary encoders used to sense the speed of the transport unit. So the coating is actually applied to the upper applying unit, and a sensor will detect the panel, and then the upper applying unit will be lowered down, right, to apply the coating. So this is the working basic principle of NPR. So if you look at the process, of course, in total we have more than 30 processes in this company. So the arrow actually shows the location of the machine, and before this process we have the laser cutting, right? And before laser cutting we have the upstream processes. There are quite a number of processes, and finally we have downstream processes including final test and packing. Okay. So to go more elaborate on the concept of NPR that I discussed earlier, right? So this is the working mechanism of NPR. So we have panel, which is the product of this company. Okay, so it's shown here. Alright. So we have certain mechanical instruments, and then we have the upper roller and the bottom roller. Okay. So the operation of the NPR is basically involves activation of the material circulation system. Once activated, the coating material circulates continuously between the material container and the applying unit. So this is how it works, and this is how company X gets its money from. Alright. So the material flow is controlled via a flow monitor in the feed pipe. This film is rolled onto the surface of the workpiece, passing through the roller gap by the applying roller pressed against the panel. Electrical material pump sucks the coating material from the material container, and the coating material distributes itself in the roller gap. The feed rate of the coating material or cleaning agent is controlled by the metering valve built into the feed pipe. The material pump is continuous operation in order to ensure uninterrupted circulation and movement of the coating material. So we have a pump that sucks the material and channel it to the roller coater. Alright. So this is how it works.
You can use pointer. We have pointer here. Not this one. The first one. Easier.
So occasionally we do see some mechanical induced failure mechanism of NPR. So given the nature, as I mentioned earlier, we have the applying unit, we have material pump, metering valve, flow controller. So we have, given the nature of mechanical complexity of the panel coating and the potential failure which is usually associated with it, the need for a system to address potential failures is imminent. This is very important as the event of such as mechanical failures. The panels will move through the applicator to the next station without any coating, and the color of the panels will not give any indication of the non-coating situation. Due to the panels will escape the inspection point after subsequent process and will end up at the finishing where it will create some process issue. So normally there will be about 250 products that will pass through this machine without coating before detection, and these panels will be scrapped. So this is a major wastage for the company. To what magnitude wastage that we are looking at, I will show this in the next slides. So what does this mean to company X? Okay, under tangible loss, it has the product being scrapped. So when you have a product scrapped, you have monetary losses, delay in shipment, and also yield impact. And at the same time, we also have intangible losses, which is the man hours to sort out the scrap product, material wastages, and other wastages as well. So as I mentioned earlier, given the nature of complexity of the whole process, we need a system to address the potential failures. Okay. So because of this, we need to create a system that works and save the panels for this company. Right? So a preliminary summary of all that I have gone through so far. Alright. So what this shows is that we need to control the failures, and since the NPR is full of many possibilities that could contribute to failures, there is a need to detect the condition of the panels in the event there is a mechanical failures or other failures as well. So an opportunity for improvement. Literature review was done to identify the best approach for the solution, and Kaizen was identified as a medium to resolve this issue. Okay, now moving on to integral part of my research. Right? So my research objective are as below. The first one, to investigate and analyze Kaizen usability and effect through literature review. Next, to develop a usable solution within the organization that can eliminate the possibility of defective panels, reaching customers through a Kaizen event based on relevant literature. To demonstrate, evaluate, and discuss the practical usability of the developed solution and its influence on.
Roughly how many sources you have been referred for? I mean, in this literature review.
Okay, I went
background study.
Yeah, I went through more than 150 literature, but out of that, 100 was directly applicable to my research.
Okay.
Next, I move on to my research question or RQ. Right? What will be the best improvement solution that can be done to ensure early detection of non-coated panels using Kaizen method for framework? How usable and effective will be the solution developed using the Kaizen framework in the organization? How can the developed solution influence and improve the organization performance level through a Kaizen event, and is cost reduction possible by using Kaizen method?
So you mainly aim to use the Kaizen method to eliminate the negative photoresist.
Yes. My plan is to use Kaizen as my framework to develop a solution for this problem.
Okay. Okay.
Okay, as I mentioned earlier, there were a lot of scraps, and this is my main motivation of study. Right? Each time the defect occurs, company X need to scrap almost 200 product with a potential value of USD 200K. The cost does not include the intangible costs and there is always a possibility of this scrap reaching customer, and this is a big problem for this company. Because as an MNC company, we keep high on our yield, and if a defect such as this reach a customer, it creates a negative impression on the company, and this is far more worse than the losses in the monitoring. Okay. So every year it was noted, based on the historical data that the company has, it was noted that the problem happening at least several times a year and becoming a big issue in company X, as it affects its ability to deliver the products in time, which impacts the company name, and at the same time company is also subjected to high wastage in terms of product scrapping and the manpower needed to rectify the issue. So every year we see that, okay, first of all, the company X, its product that it produces is being delivered to, it has a ready buyer. So whatever it produces is being sold to the customer. So whenever we have like 200 panels being scrapped, then the company will need to work out a plan to come out with this amount, and that's not possible because we are running 24/7, 365 days.
How many chambers of this system is available in your company?
Okay, in my whole company we have 24 machines such as this. Right? So the scope and limitation of my research, the research will be centered in a single company, right? The company that I'm working on, and the research work is done to address a problem from one single type of equipment, which is the NPR from this company. The research will be characterized by using Kaizen as a platform to drive for improvement. Next, I move on to the hypothesis of my research.
Yes.
The following indicates the parameters that were planned to be included in DOE and tested in order to realize the nature of failure. So, from the Kaizen literature review that we did, we found out that design of experiments are the best way to test out any possibility of failures. So the hypothesis selected is based on the most probable occurrences, factors that were derived from previous experience and past records. Okay. So based on the study done, we come out with 4 hypotheses. First, abnormalities in solution dispensing. Secondly, high humidity causing coating to evaporate. Abnormality on the incoming panels or the products. Number 4, failure on mechanical assembly parts. So when we talk about mechanical assembly parts, based on our historical and previous experience, we identify these three parts as the main culprit for this problem. So therefore, we listed down that under our hypothesis. Okay. So before I go further, I'll just go through the organization of the thesis, right? So chapter 1, introduction to project, where I will be introducing the company, where the research is centered, the problem faced by the company, and also about Kaizen. And I will also talk about my objective, scope, limitation, motivation of the research. And the structure of the thesis is also narrated at the end of this chapter. Alright. Next, on chapter 2, I'll be doing the literature review of Kaizen, discuss a thorough literature review on the Kaizen and its impact in bringing improvement to manufacturing industries. This is done by going through literature review on publications. Next, for chapter 3, I will provide detailed explanation on the developed solution and how the solution came about. It will also provide the explanation on the hypothesis developed during the course of conceptualizing the solution. On chapter 4, I will provide detailed explanation on results and its impact to the company. The improvement results are scrutinized further by using a JMP software. JMP software is an advanced statistical tool that's being used by most of the companies. Under this, we will be able to do a DOE or any statistical study that we want to do.
When you consider about statistical process, they are few because based on statistical process, they call SPC1, SPC2, and so on. Yeah. And they also use some kind of technology called Six Sigma. So to what extent you have used what was the software name?
JMP.
JMP.
So under JMP, I have used it to do statistical or data scrutinizing stage. So my company actually practices Six Sigma. Alright. So, but I use this tool to scrutinize my data. Right.
Okay, go on.
So next, chapter 5. After going through all these chapters, in chapter 5, I will derive a conclusion for the entire outcome of the project by going through the impact and improvement brought to the company by doing the solution. So under chapter 5, I will talk about the impact and the improvement that has been done using this project. So my references, after that, I will have my references list all the international publication, periodic journal, conference, book text, and online lectures that I used for my research here. Okay, summary of literature review. Right. So one of the best method to create a defect-free manufacturing will be Kaizen. Kaizen is a Japanese word that has become common in most of the Western companies. This word indicates a process of continuous improvement of the standard work way of work. So as I mentioned earlier, Kaizen and continuous improvement are in the same league, and or any continuous improvement that is being done will narrate back or correlate back to Kaizen, right? So as I mentioned earlier on my previous slide, the word Kaizen is actually a compound word involving two concepts, Kai and Zen, and it also comes from the Gemba, right? Continuous improvement or CI is one of the core strategies for excellence in production. If you look at any company, right, so they will always talk about how to be better than their competitor, or how could they save money, or how can they produce products that is zero defect or at least better yield. So all that will boil down back to continuous improvement, CI. So if you take any companies now in Malaysia or global for this case, you will see that they have a comprehensive continuous improvement plans. A company without a continuous improvement plan will not succeed in the long term, especially in our globalization now that's happening across the world. So it calls for endless effort for improvement, involving everyone in organizations. As I mentioned earlier, it should be bottom down. Okay, some of the techniques of Kaizen that I retrieved from based on my studies, right? So Kaizen is actually an umbrella, and under that we have many tools that are associated with the Kaizen. For example, custom orientation, Six Sigma, as we mentioned earlier, TPM or total productive maintenance, just in time. This is what my company practices. Small group activities, automation, suggestion system, discipline, Pokayoke, error proofing, right? So we have custom orientation, fulfilling the customer needs, EQC, statistical process control, and other statistical tools are necessary to understand problem. So in my company, we are using JMP, robotics and automation, right? So a point that we need to remember is that automation can help, but it's not the ultimate solution in every problem. Quality circles, employee engagement, this is very important. We need to engage employee to produce the quality, right? Suggestion system, everyone can suggest a change, even if he or she doesn't work in the process. So the whole project comes with a suggestion system, right? We started off with a suggestion system, and later part you will see how much we have saved for the company, right? Discipline in the workplace, 5S method everywhere, TPM, maximize performance of production, Kanban methodology, smooth of production process. This is actually basically refers how we manage the product that we produce. Just in time, smooth cooperation with business partner. So we produce just in time, eliminate wastages, quality improvement, key to success. Zero defect is the concept of ultimate improvement. So whatever improvement that we do, the ultimate goal will be the zero defects, right? Small group activities help enhance teamwork, cooperative relationship between managers and employees, improve information flow. Productivity improvement is the effect of the program. New product development is required to keep us in the business. Right?
Okay, just a moment. I have a question. You have written there Poka-yoke. Poka-yoke is basically a problem-solving tool, right? How does that differ from the Kaizen?
Okay. Poka-yoke is actually error proofing. It means error proofing.
Okay.
So, if let's say in your day-to-day work you encounter a problem, right? So this problem is causing, say, yield, right? Right. So what you do is that you go and study the process and do something to do as an error proofing. For example,
that is what you want to do with Kaizen, right? Because using Kaizen,
yeah,
you want to eliminate. You want to eliminate the photoresist. The other topic.
yes.
Yeah. So if that is the situation, then instead of using the Kaizen, still we should be able to use the Poka-yoke.
Okay. Kaizen is the umbrella that governs all these. All these actually goes under an umbrella called.
Become a sub of the.
Yes, it's part of the Kaizen.
So that means when necessary comes, you will be using the Poka-yoke under the Kaizen method.
Yes.
Is that
Okay.
what? Yeah.
Okay. I have chosen Kaizen as my framework. So definitely when I do this project, there must be a lot of activities that I do. So the improvement that I do for the particular machine, it goes under Poka-yoke. And how this idea came about is through the suggestion system. Alright. So when I have this idea, right, definitely I need to engage other stakeholders. So there comes in the small group activities. Alright. So and when I do this project, definitely I need to engage the maintenance team as well, because there will be some new maintenance that need to be done. Right. So for under that, it goes to under total product maintenance. And my ultimate goal is to create a zero defect, to run my processes at 6 sigma level. So therein comes the 6 sigma. So whatever I do want my panel to reach customer, the defect panel to reach customer and create a bad image to my company. So therein comes the customer orientation. So all these are under an umbrella called the Kaizen.
Okay, good.
Okay, summary of the literature on effectiveness of Kaizen philosophy in different fields of application, especially in manufacturing industries. The case studies are the important means to check the effectiveness of Kaizen philosophy in different fields of application, especially in manufacturing industry. Many researchers have performed case studies to cover a wide range of benefits like increased productivity, improved quality, reduced cost, improved safety, and faster deliveries. So these are the things that we want